Okay, guys. Good evening, everyone. Welcome to the second event of Computational AEC. My name is Haas, and along with Giovanni, we run this event and basically rely on people like you to come present and share your knowledge with everyone. So if you have anything to share, if you want to present the work that you have done, or you have some knowledge creating a software or working with a software and can conduct a workshop, we welcome to have you on our next events. Tonight event is sponsored by Swinburne University for the facility and the venue that we have, and also Autodesk, which covered the other cuts of the event. You can get in touch with our Twitter handle there, and email address on the website. On the website, there are links for news and anything we find interesting in this realm. We'll share it there. So some interesting stuff there if you want to check out. Today's speaker lineup, we have Kai from BKK Architects. He's going to talk about pyRevit and how it's used in Revit. Nathan Luke is going to walk us through some of the geometry gym tools, and we got Alessandro, who's going to show us some of the work that he has been doing on the VR stage. So without further ado, I'll pass the stage to Kai. And short introduction, Kai is a graduate of architecture, currently working at BKK Architects in Melbourne. Having graduated at the end of 2016 from Monash University, Kai has experience primarily working in infrastructure and rail, with previous projects including the Westgate Tunnel, as well as several level crossing removals throughout Melbourne. Right, welcome, Kai.
So hey everyone, my name's Kai. I'll be your first speaker today, and I'll try and give you a high-level and short and sharp presentation on the pyRevit plugin. So also, this is my first presentation, so I'm actually quite nervous, so apologies for that. So a little background on myself. So like Hoss said, I'm a graduate working at BKK Architects. So we're a medium-sized firm of about 30 people, and we've got a broad portfolio of work ranging from individual residential homes all the way up to the large-scale infrastructure projects, like the Northeast Link project that I'm currently working on. So since we're a medium-sized firm, I have to wear a few different hats in the office. Some days I'm the computational designer guy, modeling some fancy parametric geometry, and other days I could be working with my BIM manager, Ewan, who's here today, on some workflow to help documentation, or doing a typical grad work in the trenches, so to speak. So on a personal level, I'm really interested and excited about the potentials of computation in the AEC industry, in both design and the delivery of the built environment. Today's presentation will be more on the practical side, but I hope it can still provoke some interesting discussion. So after today, these are the learning objectives that I hope you guys will get out of my presentation. So the first one being getting an understanding of what pyRevit is and how to get the most out of the plugin. The pros and cons of using pyRevit compared to, I would say, the typical alternatives for scripting in Revit, so Dynamo and C# specifically, as well as learning the advanced features available with pyRevit, and also how to get started with pyRevit and understand how the scripting works, and also mapping out our process for how we manage the scripts and distribute them throughout the office, as well as giving you guys a clear direction of where to go next and dive deeper into the plugin and get the most out of it. So what is pyRevit? To put it simply, as I can, pyRevit it's an open source plugin developed by Ehsan Iran Nejad, apologies for the pronunciation, for Revit, which not only gives you an additional tab of tools, but more importantly allows the user to sketch out scripts and add-on ideas using Python programming. And I think has many advantages over more familiar tools for scripting in Revit like Dynamo and C#. So for those of you who are familiar with Revit Python shell, pyRevit is sort of like a natural next step because it allows for the creation of much more mature Revit workflows and add-ons and plugin behavior. Next. Oops. So this is what pyRevit is probably most well known for, I would say, in typical architecture firms or engineering firms in Australia. So I won't go into too many of the details, but pyRevit basically ships with an existing suite of quite powerful tools, and some of them are already really popular. So for example, the Make Pattern button here, which lets you create your own custom hatch patterns, as well as managing sheets and revisions. I won't dwell on that for too long because, because I think the real power of pyRevit is that you're actually able to create your own custom toolbars and scripts which can be loaded like any custom add-on as like a typical C# plugin. So this allows for more powerful functionality to be abstracted away in these buttons here and easily be used by non-technical staff. So I've been working with my BIM manager, Ewan, who's here, to develop a set of custom automation tools to be used by the Revit staff in the office and to help streamline and reduce pain points in our sort of day-to-day work. So things like creating room plans, views based off a list, or isolating objects, just simple little things like that so far, but we've got ambition to go a bit deeper. Why would you use pyRevit? So my first point would be that there's no more spaghetti. So although tools like Dynamo and Grasshopper greatly lower the bar of entry needed to get into algorithmic design and automation, once you go beyond a certain level of complexity with your scripts, you quickly start to see the flaws of the visual programming paradigm. So I'm just comparing the two here in these images. If you look at the image on the left, this Dynamo graph, which I would say most of us are familiar with, is actually really well organized, but it would still scare away, I think, most people who aren't already intimately familiar with it. Textual-based programming, on the other hand, is much more concise and easier to manage once you start getting into it, and has really well-established design patterns based off computer science for organizing your work, which I would say is the exact opposite of visual programming, where the deeper you go, the more difficult it is to actually organize your workflows. So furthermore, Dynamo is actually misses quite a lot of functionality, which is luckily made up by the community via the package manager. But I think it's also interesting to note that extra functionality is usually Python code embedded within custom nodes. So my next point, which is probably the most provocative slide in my presentation, and I don't want to bash on Dynamo too much, but I think that its days are actually numbered. So Rhino Inside by McNeil, I think has the potential to be a real game changer for the industry. And I could easily see Grasshopper taking over Dynamo as the dominant scripting interface within Revit for creating geometry, while plugins like pyRevit will become the main interface for general automation. So I'm really looking forward to Nathan's presentation later on and seeing how Rhino Inside is being leveraged for other plugins. So moving on from the Dynamo argument, I actually think it's also better than C#, which also could be a bit controversial. So although C# is definitely way faster than Python when it comes to execution time, it's a lot slower when it comes to in-house development. So with Python and pyRevit, you don't really have to worry about compiling. You don't have to worry about declaring any variables like in C#. You just write the code and you hit run and get the results. So in the case that you do need, say, heavy computation, or you decide that it's worth the time investment to create a full-blown Revit add-in, go ahead and use C#. I think it's fine. And I think that this is what Ehsan himself sees with pyRevit, in the sense that it's a rapid prototyping environment. So pyRevit can be used to complement the C# development process rather than being counter to it. And just moving on from that, so we'll just go through some advanced features of pyRevit. So like Dynamo, pyRevit actually has quite a mature extension manager where you can pick up scripts from other people. pyRevit can actually run Grasshopper scripts from within using the Rhino inside. So I think that's actually a recent addition to pyRevit. So I'm really looking forward and excited to see where that's going to go. And also, pyRevit allows for a telemetry server. So I'm actually not fully across the details on the technical side here, but the gist of it is that pyRevit can send off statistics about its scripts to an external database, so you can sort of manage and analyze what's going on with your users in your firm or your business. And it also has WPF and XAML integration, so you can use Python code with pyRevit and then have a front-end user interface. So I'm just highlighting it there with a WPF dashboard. And also it will implement I think CPython as well, which I believe is a different implementation of Python language, because pyRevit is based on IronPython rather than the typical Python. And then finally, just check out the roadmap, because Ehsan updates it regularly. All right, so just getting started on how, if you wanted to use pyRevit in your firm, how it's actually set up. So this is I'll try and keep it brief and not get into too much detail, but it's actually really simple. So there's no code behind, there's no boilerplate code like in C# where you have to wire up all of your logic to say icons and little buttons and things like that. The way pyRevit works is you just have a folder system. So if I wanted to create, so if I go back to this tab here, if I wanted to create this tab, the BKK tab from scratch, all you would have to do is you'd have to create the folder, and you just have to add the dot extension, and that will know that you're creating a new sort of extension using pyRevit. And then from there, it's the same dot notation, so dot tab, that will create the BKK tab there, BKK dot tab. And then further on, utilities, you can add dot panel, which will create that kind of the little panel. I've sort of cropped it here in the image, but you get the idea. And then going further down in the layer structure, you can actually add buttons yourself. So dot push button will be these simple ones, but you can also add pull down. So for example, renumber doors. And then finally, to actually get into the script itself, you can add icons by labeling it icon.png. And then script is actually where all the magic happens, so to speak. And that's the Python that creates your logic. And this is an example of how we work in BKK internally. So the way I've had it set up is that I use Visual Studio with GitHub for version control for the pyRevit scripts, which all reference to a database which links to all of the Revit users. Sorry. So just as a case study, for example, going back to the Revision Cloud button, this is an example tool that we use. So get Revision Cloud data will basically just pick up all of the Rev clouds in the document and spit out an Excel spreadsheet. So this is just one one tool that we use at BKK with pyRevit. And then this is another case study. So I just wanted to highlight this one to show the capabilities of the different UI options you have that are built into pyRevit. So it's actually really easy code where you can get user input, drop downs, and that's how I think a really powerful capability that pyRevit has, which the equivalent in C# would take quite a lot of effort, I think, to build something like this, or at least a lot more effort than with pyRevit. And then why not use pyRevit? So obviously I've gone through the pros, and now we have some drawbacks and risks of using pyRevit. So it is a slightly higher barrier of entry compared to, say, Dynamo, because you have to learn how to code But Python is actually very simple and easy to learn, and I think it's actually worth it. And pyRevit lowers the bar even further than, say, learning to code with C#. And also on a business level, usually it's maintained internally by a single developer. So for example, myself. And so there's a risk associated there where if I get sick or if I leave the company, there's a liability and a vulnerability for the business. And then finally on a larger scale, so it's maintained entirely by a single developer, that being Ehsan. So there's a risk of becoming abandoned where he retires or something, and then pyRevit, no one maintains pyRevit. But those risks can be mitigated. So I wanted to put this slide on its own to really ask for people to maybe consider supporting Ehsan via his Patreon page. Because a lot of firms may be relying on this for critical processes that they have. And so I think this is a really good way of giving back to Ehsan for all the hard work that he's put in. And I really hope it happens. I'm trying to convince my bosses to do it. So conclusion, learn Python. It's worth it if you don't already know how to code. And I think it's perfect for smaller or medium scale firms because custom scripts can be quickly and easily deployed throughout the user base without too much effort from the development team. And it's also great for large scale firms because their in-house sort of more advanced software development team can use pyRevit for rapid prototyping for applications in Python. And when they feel like it's time to when they feel like it's worth the investment of developing a proper C# plugin, they can do that, and the prototype is already there in pyRevit. And finally, some resources. So pyRevit, Ehsan has a really great YouTube page. Well, I've learned everything that I know about pyRevit. It's also fully documented on GitHub. And also his new blog location is there, which has a lot of really in-depth tutorials and walkthroughs. For general Revit API, there's a Revit API docs, as well as the building coder, where you can get expert advice. And then finally, the way I started using pyRevit was just converting existing Dynamo scripts that I found on the internet. And Parametric Monkey and Aussie BIM Guru do a great job of giving advice, as well as the Dynamo BIM forum. And then finally, Python itself, automate the boring stuff, I think is a perfect starting point if you want to learn Python. And that's why I learned it myself. And it doesn't go into too much detail, but I think it's just enough to get started. And that's it. Thank you for your time.
I think it was great for you first time.
So I was just so nervous. I can't believe it. Oh, thank you.
Is there any questions from Kai? No? I have a question actually.
Yeah.
So when you update your .py files, when you deploy them on the server, is it going to automatically
Yes, so it's a live link. So every user in Revit will have pyRevit installed, and then from there you can tell it to reference to a folder which is on the server. Yep. So I should have explained it more clearly in the presentation. So whenever I update a script, it dynamically updates to whoever's using it. Okay. So when it's not a .dll file; it's like baked into that into the library.
Yeah.
It's always referencing the Python script.
Yeah. That's a great thing, I think.
I think it's really
yeah, because with the normal plugin scenario, you have to restart Revit normally to get it updated, and normally users open Revit like 7 days and they don't close.
You don't have to worry about installing or anything, it's just always there.
That's a great advantage. All right, so next up we have Nathan. Nathan actually wanted to live demo some of the features of geometric gene tools, but unfortunately we have some technical problems. But I'm going to ask him to maybe record a live demo and share it with us, so we can include it in our video and share it later. But he's going to show us some screenshots of the tools. Yeah, so just have to plug it. Maybe take this one off. So a little bit of biography about Nathan. Nathan completed a degree in civil and infrastructure engineering at RMIT and has just over 8 years experience as a consulting structure engineer. After working for Oracle for 6 years, he spent 2 years working with Borough Apple in the UK prior to returning to Melbourne. Late last year, Nathan currently works along with John Merchant at Geometry Gym and helps with software development, training, and support of the Geometry Gym plugin tools, as well as providing specialist consulting in regards to parametric design and BIM data workflows, optimization and rationalization of complex structures, and automated fabrication and drawing production. So if you have any questions about Geometry Gym tools, Nathan is a wealth of knowledge.
All right, g'day everyone. How you going? Yeah, my name's Nathan. Thanks for the nice introduction. Thanks for the first presentation. Yeah, I was going to do some live demo of some stuff, but I couldn't get my screen connected. But I've got some screenshots, and most of the stuff you can find on YouTube or anyway. I'm just going to give a quick little introduction on Geometry Gym. I don't really want it to be a sales pitch or anything like that. And then I'm going to talk a little bit about the latest development of Rhino inside Revit and what Geometry Gym's doing, or how we're sort of utilising that for our advancing our plugins. But yeah, so just a little bit quickly background on myself. I work for graduated civil infrastructure engineering. I worked as an engineering structural consultant for about 8 years. I was kind of pretty lucky, I think, in my career. I've sort of worked on mainly sort of stadia and complex structures, and that's kind of, I guess, what's driven me into more of a computational type field. I worked on Mark Arena sort of coming out of university, and I guess I could sort of say that I did that the hard way in terms of how you build geometry in a structural analysis model, trying to get wind result data from Excel into a space gas model, which could take potentially months, or it took me a month to do it. Whereas now I could do it in a couple of minutes and update that as it sort of updates. But yeah, so then spent 2 years in the UK working for Borough Apple on a stadium in Qatar, and a couple other things, and then had the opportunity to come and work for Geometry Gym late last year when I got back. So has anyone not heard of Geometry Gym? Most of you guys have heard of it. Oh, that's good. Yeah, so basically it's 10 years old now, and obviously founded by John Merchant about 10 years ago. Sort of the first, I guess we kind of sort of see ourselves as kind of trailblazers in interoperability between software programs. We're both structural engineers, and it sort of started out, I guess, trying to link Rhino and Grasshopper with structural analysis programs, and that sort of formed a bunch of plugins, or a base of code, which we sort of developed to link it with a whole bunch of analysis programs. And through that, John learned about sort of OpenBIM and IFC, and we started to use that a lot for linking the structural analysis programs, and then sort of took it a little bit further as he learned more about the whole OpenBIM stuff, and started to look at Revit and how you can sort of use IFC as a base data, a sort of database of geometry which you can sort of link with different programs and have different attributes and stuff like that. So we have a whole bunch of structural analysis plugins for mainly Rhino and Grasshopper. Also a bunch of BIM plugins for Rhino, mainly Rhino and Grasshopper and Revit as well. And we also have plugins for Tekla and Navisworks to sort of enhance their functionality. And then we also do offer other services as well, sort of freelance programming, sort of BIM strategy and stuff like that. And also we do specialist contracting for some complex geometry projects as well. Yeah, I won't go through this in detail, but there's three of us now. There's John, myself, and Scott Beasley up in Sydney, who is more of the hardcore BIM side, quality checking of models and linking 3D models and 4D, 5D type stuff through IFC. I mean, I guess you guys most of know this sort of stuff, but you know what generative BIM and parametric design is used for. But you know, you can use our plugins to sort of help, you know, with I guess linking with structural analysis, and then the main other parts that I think a lot of people are starting to find now is the automating of the BIM data and extracting data from models and IFC files and all that type of stuff, which is a lot quicker now than, say, trying to interrogate a model or whatever. Yeah, there's just some more of the plugin stuff we have. So, you know, in terms of our Rhino and Grasshopper plugins, we have, you know, you can import structural analysis files from any of those programs into Rhino to get sort of geometry. If you don't have that structural analysis software installed, then you can sort of import it into Rhino, zoom around it or whatever, manipulate models. Also import, export from Grasshopper, so import structural analysis models into Grasshopper, which will basically create a structural analysis database which you can manipulate sort of within Grasshopper, export directly to IFC from that, sort of if you want to import into REWILD or something like that. We have one-click exports from REWILD for structural analysis as well, that sort of include sort of your structural snapping and stuff like that. We also have import and export from Karamba 3D, so I'm not sure if guys are structural analysis people here and using Karamba, but you know, if you're doing I guess a schematic design and you're using Karamba to do structural analysis within Grasshopper, and then you want to export that to, say, Spacegas or SAP or something to do your final design, then you can do a sort of a one-click export rather than have to rebuild the model or whatever. So yeah, I mean, structural analysis plugins, we basically, for those who sort of are not fully aware, it's basically what we provide is an extension to Grasshopper that allows you to specify materials and structural, everything you need to basically define in a structural analysis model, and then also allow for automated solving, result extraction back into Grasshopper to do sort of design and stuff of what you want. We also allow in some of our plugins basically an automated design triggering, so you can set up design members in Grasshopper and trigger the design and get back utilizations and stuff like that as well, which you can integrate with evolutionary solvers and stuff like that to optimize structures. Yeah, spoke a little bit about, we also have put some smarts into our structural analysis exports, where you, obviously, I don't know, as a structural engineer, I used to find if I was getting a model from an architect, trying to make a structural analysis model out of that can sometimes be quite difficult. So we have tools that allow basically I'd say a user can define planes to snap geometry to, define bounding areas that nodes will snap to, and it's basically a sort of instead of a one-click button to that suits every structure, which we all know it doesn't. It allows the user to sort of be a bit more hands-on in that respect, to get better structural analysis models out of, say, a model you might get from an architect or a shop detailer or something. Yeah, direct export to IFC. So if you've created a Grasshopper model for an ETABS or whatever, you can directly export that model to IFC, which you can import into REWILD or whatever. And all of that similar stuff is we've got a REWILD plugin which basically links Grasshopper with REWILD. I'll speak a little bit about that later. and also IFC, we have our own IFC plugin, so importing IFC into Rhino, manipulating and creating IFC files within Grasshopper as well, so generating like freeform shapes and stuff like that. So that was a bit of a quick rundown on Geometry Gym. So yeah, one of the, I guess, I think it's, not every day you sort of get excited about something in terms of interoperability in the computational space. And when I learned about this, I think I actually kind of got quite excited about what this can do. Like, I don't know, have many of you guys sort of had an issue with getting geometry from Rhino to Revit or Grasshopper to Revit? There's a million different ways. There's 10 or so plugins that have been developed for this exact thing. Geometry Gym have our own plugin for Grasshopper. People export, go to Speckle, bring that back into Dynamo, then try and build Revit geometry or whatever. Our way is to export an IFC file basically to your computer and then import that IFC file back into Revit. And it kind of seems like in one sort of foul swoop, Rhino has just developed this plugin or this technology, which basically what it allows is Rhino and Grasshopper to be executed as a Revit plugin, basically. So it gives Rhino and Grasshopper direct access to Revit's API, and it also gives Revit access to Rhino's sort of comprehensive sort of geometry and NURBS library and API, basically. Whereas in the past, you're sort of working with two separate entities and trying to connect them together. So yeah, it is quite exciting. So, basically at the moment, who's tried this, by the way? Cool. So, but at the moment, it only works with Rhino or work in progress. But I think hopefully when Rhino 7's released next year sometime, it should be sort of inbuilt within. And basically, so anyone who's got Rhino 6 can install it. And all you have to do then is basically download a Rhino Inside installer as well, which allows you to sort of work within Revit. I mean, it is still a work in progress, but it is quite powerful already in what you can sort of do. I was going to show some demonstrations, but I'm going to have to stick to presentation slides, which isn't going to be that great. But anyway, sort of the benefits, I guess, is you've got you can do a direct import of a 3DM into Revit, basically, quite easily. I know you can do that in the past via a file, but people have had all sorts of issues. You can preview Rhino geometry within Revit. You can extract geometry from Revit directly into Rhino, baked directly into Rhino. You can obviously generate Revit elements, direct shapes through Rhino and Grasshopper directly. You can manipulate parameters, get parameters, set, create parameters on objects sort of within Rhino and Grasshopper. There's also a Grasshopper Player, which you can, which is similar to Dynamo Player if you guys have used that, which basically can execute a Grasshopper script from a button. And then there's the other thing is you can also select and reference Revit geometry and Revit, say, lines, vertices of Revit elements and into Grasshopper, sort of a similar way you'd do it for Dynamo, but using Grasshopper. So this image here is basically the add-in image that you get when you sort of log into Revit. And you can sort of see you've got a Rhino button, you've got a Python button which you can code in Python and access the Revit and Rhino APIs or whatever. And then you've got a Grasshopper button as well. If you open Grasshopper directly, you basically Rhino started to develop their own plugin which is specific to Revit. So this is where you can start to sort of select model categories. It's kind of I guess a similar thing to what you'd expect. Well, the components might be similar to what you'd expect in Dynamo or whatever. But you can start to filter, start to build elements or whatever. So this will only be in the Grasshopper that you open from Revit. And then the other thing is they've added a whole bunch of parameters as well for Revit as well. So selecting elements, selecting edges, faces, vertexes to bring into Grasshopper to reference or whatever. So this is sort of, I'll just run you through some of the benefits I was talking about before. But so if you click on the Rhino will open, and then from there you can basically open a Rhino file or whatever. So it's a massing of a building or whatever, and you can hit, I think it's that sample 6 button, and you can hit that and basically that'll pull up the Rhino geometry within Revit. So you start to get a sort of a reference of where that is in space, and that's just a preview geometry. As you move it around in Rhino, you can that'll update your preview. You can also, so you can also import that geometry directly into Revit. So if I've got a file which I've got from someone and it's a 3DM, I can import that directly and start referencing that file within Revit if I want to start building or whatever off that. You can also get basically a preview geometry of anything that you're doing in Grasshopper. So if I've referenced a bit of, say, a surface from Rhino. So in this instance, I've got a Rhino surface that I've built. I'm using Grasshopper to manipulate that, or I want to manipulate that in Rhino. I can get a preview of how that looks in Revit, or say I've baked some images or whatever. But it kind of shows how you can start to reference geometry from different aspects. So I can reference from Revit, or I can reference from Rhino and also bring that into Grasshopper. This is one of the Rhino images, but it's basically what they're doing here is they're going from Rhino into Revit. So I've selected my floors, my floor plates. I basically I'm saying I want it to be a floors, and I'm basically baking that geometry directly into Revit. So it's pretty neat. The other thing that's pretty cool, which is, say you have a building or whatever, and I know, like, for me, being a structural engineer, sometimes you might get a model from an architect or something, and you're wanting to do some sort of analysis, or you're wanting to, like, get just the outer surfaces or whatever from the walls or whatever, and you don't really care about anything else that's in the model. So you can start to do that type of stuff, is filter out elements, get their geometry, and then bake that directly into Rhino. So, and you can bake that to whatever layer you want. You can set up a script that will bake it to your certain layers or whatever, so you're not exporting, so straight from Revit and then trying to have to manipulate that geometry down the line or whatever. So I think that's pretty cool. Yeah, I mean, and then the other thing, it does allow you to sort of mess with parameters and start to define parameters and stuff like that, and work with your model data as well. So it's kind of everything that I guess you want from being able to manipulate a Revit model for parameters and stuff like that. It allows you to do stuff like that. So the Geometry DIM plugin that we're doing for Rhino Inside basically allows, it's a little bit different to how the McNeil guys have developed their plugin. So it's basically the same as what we as our older plugin, which was basically write an IFC file from Grasshopper and then import that in through our IFC importer. But because of how I said before that Rhino is sort of within Revit, we can basically now we've got a button which is basically a bake to Revit button instead of a bake to IFC file, bake to Revit button. So when you're inside Revit, excuse me. When you're inside Revit, that IFC file will get directly baked to the memory, and then it will update Revit automatically. So it's exactly the same as our IFC importer, but we can just do that on the fly now. So everything. So I guess with IFC and the benefits of that can sort of be integrated. The other thing here is you don't actually need to be in Revit developing a script. So we develop all our, you can be in Rhino developing a script, which you can then open Grasshopper. Then you can open Revit and just hit that bake button to Revit. You don't have to be, if you've got people that don't really like working in Revit and they just love working in Grasshopper, then you can develop your script using our normal geometry and Revit components, and then bring that over later and import that directly into Revit rather than using an IFC file. Or you can still export to IFC at certain times along the project delivery or whatever. But that's a little bit different. So you don't actually need any of the Revit components that are being used within Revit. So from the McNeil guys, but it does streamline that sort of the process of importing and exporting geometry. So that's kind of all I've got. Sorry I couldn't do the live demonstration. I hope that wasn't too much, but I'm sure if there's any questions or anything like that.
I have a lot.
Okay.
Is there anyone with questions?
I have one. Does the geometry get baked into Revit, or it keeps like alive, or a link alive?
Yeah, so basically you can either preview it, or there is the direct shape to Revit. So there is a component which is basically element or direct shape to Revit. So as soon as you activate that, so that component will on the fly be updating actual Revit elements. So
if you close Grasshopper and open it again, like Dynamo, you cannot do it with Dynamo. Once you create the object in Revit, and you shut down the script, you lose the connection.
Yeah.
Can Geometry Gym keep the connection alive?
So the way Geometry Gym does it, is through IFC elements. So if you once you say bake that geometry to Revit, say, or that's a Revit element, it's got an IFC GUID on it. So every time, and then you can close Grasshopper or whatever and keep working in the Revit model. Every time that say you make a change to your facade and re-bake it, it will check to see whether there's an element with that IFC GUID, and it'll update that element or whatever. So it won't lose the connection. I'm not 100% sure with the Rhino inside stuff itself. So if you look at this image, this is basically they've baked floor plates, so that's their Revit elements. If you close that down, I'm not sure, you were talking about that issue before, weren't you? If you close Grasshopper down and then redo it, it sort of updates the...
Yeah, the live link will the live link will be broken. So
yeah.
the GUID, if you have it all open, it's fine. It updates dynamically.
Yeah.
But if you close Revit, or I think Rhino and Grasshopper as well, the GUIDs aren't maintained, so it creates a new geometry over the top.
Yeah.
That's my experience with it.
Yeah, and I think that's I think that a lot of people have that sort of issue, and I think that's why our Geometry Gym, that's why we've sort of done it in this way. So whether we've got a live link or not, we're using a GUID to sort of understand whether that element's sort of in Revit or whatever. But.
One question from me. When Rhino starts up inside Revit, is it going to be attached to the Revit process as well? So for example, if Revit crashes, is it going to crash Rhino as well?
Yeah, I believe so, yeah.
Okay.
I believe so, yeah.
And with the custom bake tool that you have, you directly bake IFC elements. It's not baking, you basically just link IFC directly to Revit.
No, it's creating Revit elements, but we just use IFC as the transfer mechanism. So basically, we have our own IFC importer. So where we can, we'll create native Revit elements. So for instance, a beam.
Yep.
It'll get passed as an IFC beam, but it will create a Revit, a native Revit beam.
Okay.
For more complex shapes, it'll create a direct shape. Like we're just using IFC as the transfer mechanism.
Yeah.
It's still producing, I guess, Revit elements.
Okay.
It's not a link IFC. Yeah.
I've got a question, a non-technical question.
Yeah.
I just wanted your opinion on what you think, how Rhino Inside can maybe change the way the average designer works in Revit in say 3 to 5 years' time. Do you see that massively changing the way most architects or engineers work?
I don't know. I think it's going to be a good thing for architects, because I think I don't know. I guess I'm not an architect, so I don't know exactly how they work, but I think it's going to be a lot easier to do those freeform or whatever, and then bake directly to Revit or however they need to work. It just gives them a lot more flexibility. I think the Rhino to Revit link has just been a massive roadblock for a lot of people, and also the ability to sort of really do those sun shading analysis or whatever in whatever program you want. Generally, you might do it in Grasshopper or whatever in the quickest way possible, and then you can just sort of update your Revit model or whatever. I think there's still obviously a long way to go with this sort of development. And there's always those little roadblocks that you find. It's when you're starting to get into the details of things like elements sort of replacing themselves and stuff like that. But it's I don't know, it's pretty exciting, I think. And a lot of architects are starting to pick it up, to do their sort of transitioning type stuff with geometry and that. So I don't know. Does that help? Does that answer your question?
Yeah.
I think the Rhino Inside project is not limited to Revit as well. They are thinking of.
No, I think they've got heaps of.
Yeah,
so they've got Rhino Inside, Excel, AutoCAD, Unity. There's Photoshop and Illustrator. Yeah, Illustrator. Sorry. Yeah. So. Yeah.
Pretty exciting.
Yeah. No, it's good.
Any other questions?
But yeah, feel free to come and have a chat with me after the presentations.
Just with regards to your interoperability between structural analysis models.
Yep.
At the moment, you're using Rhino elements to export to the structural analysis. Do you have a link for sort of Revit elements into structural analysis software? Or
what we basically do is, so we don't export Rhino elements, so to speak. We will actually build a structural analysis database in Grasshopper, but it'll be based off, say, Rhino lines. So it'll be a line, and we'll convert those lines and the properties to a structural analysis model, which we'll throw to the structural analysis program, basically through an API, or we'll generate a text file or whatever, We do have, I showed a little bit before, we do have some, we do have a couple of plugins which allow a direct bake to structural analysis from Revit. So we've got a couple of those buttons, and they also, I guess, include that structural detection type stuff as well. So yeah, we do have sort of, I guess, a plugin that can do that type of stuff as well.
Okay.
Does that answer your question? Yeah.
Any more questions?
Yeah, feel free to come and have a chat later anyway. So.
Okay, thanks. What's the plan? We got some distractions here. Pizza's arrived. Should we have a break and some pizza? Have some pizza, and we'll continue with Alessandro. So next up we have Alessandro. Alessandro has a PhD in architectural engineering and is currently senior research manager within Arup's Foresight research and innovation team. In Arup, he currently deals with emerging technology for engineering. His interests focus on how to link computational design, digital fabrication, and innovation design to construction methods. So thank you very much.
Thanks, Ross. Hi, everyone. It will be a pretty laid-back presentation. We've seen a lot of tech stuff, super interesting. I'm giving you a more generalist overview, where I come from, what I do in Arup, and yeah, some fun stuff, hopefully to close the day. As mentioned, I am part of the Foresight research and innovation team. And so in a company like Arup, which now counts 1,500 people just in Australasia, it's important for us to stay ahead of the market, right? To monitor what's changing. And one of the ways of doing it is for us in research to, branch out to monitor emerging technology, how digital transformation is affecting and will affect our practice, and from a research point of view, try and go and reach out to the best technology we can use, bring it in, de-risk, and cater it in business as usual. We have recently released an interesting publication on sustainable development, and another interesting thing is that so we support a range of 70 to 100 research projects every year in Australasia. And the most interesting ones are those who marry digital and sustainability. So there is a strong connection between computation and sustainability, vice versa. And again, where I come from, which is architectural engineering, really helped to have this design kind of imprinting that puts you in the interdisciplinary area. For a bit more background of what I mean by architectural engineering, I'll show you a catchy video of what I did in my PhD, which again, I have focused on form-resistant structures and grid shells in the specific, which are shell structures discretized by linear elements. And it's nothing new, it's been done already, but the novelty was to use a pneumatic formwork to bend this structure. Right, Friotto was a forefather of this stuff. And Friotto was not alone, I was alone. And computational design allowed me to basically bring the project together. So from the simulation to the digital fabrication to the monitoring of the whole performance, which was done with this Arduino interface. So again, I could monitor if the simulation was happening actually as expected. Again, in parallel, go and streamline the whole fabrication process. This could be seen as a bit artisanal, but scalability here was taken into account. So again, this could be replicated probably at larger scale. And so it was a very good proof of concept to try and leverage on a technology that is available to everyone, to deliver innovation, to spend some time outdoor with your friends building this stuff, and basically try and reinvent the wheel in something already well consolidated. After a few months of preparation, this is the construction day. Right here, everything went smoothly, as you can see from the video. Not exactly, but that's part of our practice as well. So you see that the footprint is roughly 7 meters by 7 meters, and the inflation took place in roughly 1 day, so bending the whole structure. Here you see the pressure and the rise of the center of the structure, monitored with the Arduino device you saw. And well, things went pretty much as expected. Luckily, the ball didn't explode. Was a bit tricky to put it in position and lock the support, but at the end of the day, thanks to mostly grasshopper and kangaroo too, this happened. Still standing. We had very good barbecues under that, and so this is where I come from, more or less. Computational, but also making, right? So, how does that translate in Arup? Well, I think a month after I started working in Arup, this project came up. And basically, Netflix came to us asking if we could help them to make this event happening in Singapore. You might have seen the Netflix series Our Planet by David Attenborough. Super cool. If you haven't seen it, go and watch it. It's basically a series on how we are screwing up the planet. And so the launch wanted to be an event to raise awareness in all the, whoever wanted to attend, and make a call to action on, reduce your carbon footprint and so on and so forth. Very often, exhibitions, installations are very heavy in terms of carbon footprint. And what we wanted to do is try and change the poetics around. So we were in Melbourne. We had to deliver an exhibition in Singapore. Usually you design, build, test everything here, and then you ship on a plane the whole thing assembled, so you don't have any errors for on-site assembly and so forth. Terrible, because it's very heavy, again, for CO2 carbon footprint. So what we did was, try and simplify traditional methods through computational design. So I went back to my beloved computer. I showed the team some different ways to make this ramp that was required. So with the waffle system, we showed also the client that this would have saved a lot of material, a lot of weight and a lot of waste, would have saved the whole problem of shipping the thing overseas. And so what we did was just optioneer different options, see what was available on site, the thickness of the panels and so forth, send the files. We tested them here at Melbourne Uni for accuracy and tolerances. And so we sent the files, they cut the files, they assembled the files with AR, and in 1 day, basically, the thing was there. Very reduced carbon footprint, everyone was happy, and it went fairly well. This won a couple of awards at the design something, and also it will be, it's a secret, but it will probably come to Melbourne in May at the Melbourne Museum. So we are working on making Mark II, which wants to be carbon negative, not carbon neutral now. So always raising the bar. So a lot of fun, small scale. This is another application of computational design in Arup. Unfortunately, I was not in this project, but I really wish I was. This is a trellis, a structure done in the UK with the intent to minimize waste in timber structures, which often are quite an elephant in the room. Like, you want to be sustainable, but then you chop a lot of trees and there is a lot of waste because of the imperfections and this and that. So the provocation was, can we actually go and pick only the parts we need from our trees and make a beautiful barn out of wood? And so in collaboration with the AEA, our London team went in this small forest, scanned a bunch of trees, and then they had this mapping of all the parts available from the trees, and they basically went and pruned only the bits they needed to make this structure. Right, so basically you don't like erase the whole forest, you just pick the parts you need, you let the tree grow, and then by, well, computer-aided manufacturing and design, you combine the pieces like a puzzle. So robotic fabrication, you drill your fittings and you make the parts, you feed the parts together, and voila. The waste was used to create the roof, I think, of the barn. And again, another interesting example on how to be lightweight in the structural design as well. And I think there's also conceptual beauty, because trees grow to be very efficient in this direction, and we just use the trees in this direction. So, we use the fibers in the right way, sort of thing. Going back to the smaller scale, this is another project I'm currently working on. We have done something similar here. This picture is actually from that building on the road. In this case, we want to use mycelium to replace petroleum-based materials for facade panels, but also to explore a new materiality, and also to explore what we can do with robotic fabrication to create maybe more interesting panels that can perform better for sound, can perform better for fireproofing, and so on and so forth. Still at pretty early stage. We won the grant a couple of months ago, so we're still in the literature review. But here again, we want to combine computational modeling with the fabrication and have not a top-down form that we want to fabricate, like sometimes happens with architects, but have the opposite. So have the material and the fabrication methods informing the final outcome. Mycelium that we already used in other contexts. So the material is there. I think now the extra mile is find a way to actually make something useful out of it. This is a project Arup did in 2017 at MoMA, and I think it stood from July till September 2017. The tricky lesson we learned from this is that mycelium shrinks, and so actually there was an engineer on site every day to check that the structure would not shrink too much and collapse. Luckily it didn't, so good lesson learned. But again, this was also a research project, very interesting for us to learn how to here reinvent the brick, literally. But beyond that, like harness all the power behind new materials and new designs, like platforms to improve the way we shape the world. And in this like futuring direction, we also push more like speculative research. This is a project. The project is not ours, this one, but we're doing something in this direction with UNSW from Sydney, where we want to see whether we can push construction even further and not drive construction by our computation, but actually let buildings shape themselves through artificial intelligence. So the concept is to use like units that will self-assemble and self-interlock into shapes that will adapt to certain site conditions. For instance, I don't know, there's a natural disaster, you need a bridge to link the two sides of a site. Imagine you have a swarm of little elements that go on site, you have a scan of the site, and then they create a bridge autonomously. This is the direction the project is taking, more or less. So learning from nature, from how animals actually do computational design autonomously, right, and bring it back to what we have technologically available. Still proof of concept, but we should be able to deliver by May, I hope. And for more projects, you can have a look at our research review page. There is a mix of everything, digital, non-digital, sustainable, but again, we have a strong push towards new digital tools, innovation, and so forth, and roughly 70% of our research projects touch at least one digital area. So have a look. If you want also to reach out to us, you have a crazy good idea you want to develop, we collaborate with universities, with clients, with possibly future clients. And yeah, it's a way to develop our skills, to create network, and to just push innovation towards a better world. So I hope you like the presentation and the pizzas. And if you have any questions.
Thank you very much, Alessandro. All right. Just before we break, just going through some of the industry updates and the things that we found interesting to share with you. Later this year, Proving Ground published another episode of their podcast, ProveIt. They publish it on YouTube. A very good source of just learning more about computational design. If you are in computational design field, you definitely know Proving Ground. They're well known for their Launchbox package. Another one, as Kai mentioned, pyRevit introduced a new home for their project. It's now on Notion, and it's supposed to be just a one-stop shop for anything regarding pyRevit. API Docs introduced a code search feature, which basically means that you can when you're browsing the API documentation, you can also search for code samples right within the website. So pretty interesting feature if you're learning to code with Rhino and Revit. Another thing we found interesting, building a smart Australasia website. They have a section for industry events. I checked it, we weren't there, but lots of others were. And if you're in the AEC industry, I think it's a good one to check. And our friends, similar to us, the computational design community in the world, have published some of their videos of their events. San Francisco Computational Design User Group have got their own website, and they publish the video of their events. Similarly, Perth Computational Design Group, which is managed by Daniel. They are also very active in this field, and they publish all their events online. So if you want some other material to watch, pretty good stuff there. All right, that's us, and thank you very much for attending.